Hi everybody, welcome to my new channel. I will be doing mathematics from grade 10 to grade 12 on all different levels, reteaching and reinforcing and moving into more difficult examples for those of you who need it. And I hope that you will find something very beneficial from what we are about to do. Let's get started. Today we are going to do identities using compound angles, and most of the time this is done without a calculator. And being an identity, it will say prove, which means we have to keep left hand side separate from right hand side. And the first one I'm going to do is sine 15 degrees equals root 6 minus root 2 on 4. Right, very common. Let's do the left hand side. We're going to find two special angles that give us 15. So it will be sine of 45 degrees minus 30 degrees. You may use sine of 60 degrees minus 45 degrees if you wish. Both of them will get to the correct answer. Right, we are now going to use our compound angle up at the top here, the subtraction compound angle of sine. So it's going to be sine of 45 cos of 30 minus cos of 45 sine of 30. Right, into our special angle, sine of 45 is root 2 on 2 times cos of 30 is root 3 on 2 minus cos of 45 is root 2 on 2, and sine of 30 is a half. Right, multiplying those fractions, top times top, root 2 times root 3 is root 6 on 4 minus top times top is root 2 times 4, on 4, and that gives me root 6 minus root 2 on 4, and that is my final answer. I'm just going to save space by writing there for the left hand side equals the right hand side. Right, our second example is going to be prove sine of 42 plus sine of 18 is equal to cos of 12. Right, and again, it's no calculator. So we have a guide here. We need to pick up special angles and 12. So that is my guide. So we're going to do sine of 42 is sine of 30 plus 12, and sine of 18 is sine of 30 minus 12. Right, don't forget to label left hand side. Okay, now we're going to expand both of those. So it's going to be sine 30 cos 12 plus cos 30 sine 12, and the other one is plus sine 30 cos 12 minus cos 30 sine 12. Right, when you have these, you will normally find one that has a minus and another with the plus, the same fractions, and you're going to add those together and get 0. So all you're going to be left with is sine 30 cos 12 sine 30 cos 12, which is 2 sine 30 cos 12. Right, and that gives us 2 sine of 30 is a half, and cos of 12, and the half and the 2 cancel, and you're left with cos of 12. So you are left with left hand side equals right hand side. Right, question number 3. Question number 3, I'm going to have to work on both sides of the board, and that is prove that sine of 3x plus sine of 7x on cos of 3x plus cos of 7x. Right, so you will see these having increased in the degree of difficulty. That's an x equals tan of 5x. Right, again, we have a guide. We need to pick up a 5x. So that is my guide. And there are no special angles here at all. So we've got to think a little bit harder. We are going to do sine of 3x is sine of 5x. We need to use the 5x minus 2x. And 7x is going to be sine of 5x plus 2x. And underneath that, if I can draw a straight line, is cos of 5x minus cos of minus 2x plus cos of 5x plus 2x. So those brackets must add up to the original numbers. Right, this is now across the board. So off we go. We're going to expand all 4 of them, which seems ridiculous, but sadly that's what we have to do. So the first one is sine 5x cos 2x minus cos 5x sine 2x. Right, and then the next one, sine of 5x plus 2x is going to be sine of 5x cos of 2x plus cos of 5x sine of 2x. And all of that is over. I'll have to draw this very slowly. To do the denominator, we've got to do each one again. So it's cos sine sine cos 5x cos 2x change to a plus sine 5x sine 2x plus another cos 5x cos 2x minus sine 5x sine 2x. Okay. Now on the numerator at the top, you're going to find one with a minus and one with a plus. So here's the one with a minus and here's the one with a plus. They will add up to 0. And then I'm just going to use a different color. In the denominator, you've got a minus sine 5x sine 2x and a plus sine 5x sine 2x. So they add up to 0. Please don't think I'm cancelling. I'm not. I'm adding them up to 0. So carrying on up here, I'm left with sine 5x cos 2x plus sine 5x cos 2x, which is 2 sine 5x cos 2x. And in the denominator, cos 5 cos 2 cos 5 cos 2 leaves me with 2 cos 5 cos 2. The cos 2x's will cancel, the 2's will cancel, and we are left with sine 5 on cos 5, which is tan 5, and therefore the left hand side equals the right hand side. Right, and then finally I want to go back to this question here and just show you a shortcut that I feel is essential. It's not going to be an identity, it's going to say simplify. no calculator. And it's going to be a completely separate thing. If you have got, from the very first question we did, sine 15 degrees times cos of 15 degrees, I would hate to have to do all of this here in number 1 for sine 15 and for cos 15 to get down to an answer. So now we're going to go and have a look at this formula here. We will look at it many times. Today is the first occasion. If I had a 15 and a 15 and a 2, I could get sine 30. So that's what we're going to create. We're going to say I want a 2, but I can't just add in a 2, so I have to balance and put it over 2. I have not changed the value of the question. Sine 15, cos 15 is still there. The 2's will cancel if I would need it to cancel them. Right, we are then going to say all 3 of these. Sine 15, cos 15 with the 2, all of that makes sine of 30. And then it's back onto that 2 that was there, which gives us sine of 30 is a half on 2, which is a quarter. So that was something I just want to introduce to you, because I use it a lot of the time to avoid doing this. There's no reason why you can't do this. It'll just take you a lot longer. Anyway, we will be using all of this again and again. I hope you have learned something from this lesson, and hope to see you at the next one. Bye. That's it, and I hope you found this lesson very helpful. Please subscribe to get regular updates on future videos, and leave a like and a comment. And if there's something in particular you'd like me to cover, please let me know. And please share with anybody out there who you think would find these lessons beneficial.